All right. Let's have our practice semester test out. Let me get rid of this. Blah, blah, blah. All right, that's gone. All right. So practice semester test. Boom. Okay, let's go through kind of the days here, because we're going to practice up through Wednesday this week. I'll explain what we're going to do on Wednesday. Hopefully this will make sense to you. On last Tuesday, we did problems 1 through 3. So we talked about, how to do a law of exponent problem. We talked about how to simplify radicals. We talked about, the domain arranged and how interval notation works. So if you need to go back and watch that, you can do that or come and ask questions. 4, this is one we did on Wednesday last week, where we talked about how to find what's left after you subtract the adjoining piece out. We talked about how to factor. That was Wednesday's. Thursday's questions, we did number 6, which is the differential quotient, where that was the big process where you plugged in x plus h, and you did the subtract the original function, divided out everything by h. We talked about the shortcuts you should look for, and the things that should happen in the middle of that problem. And we finished with 7, where we did write the equation in point-slope form and slope-intercept form. You have to write it in both. And I think that was the problem we finished with on Thursday. Now, the forms, they're on the board. You can see it. It's right behind Madeline over here. You can see them. Those are going to be on the board semester test day. They're staying right there. So you know what forms to go to, how to write them. The big thing you have to do is find slope, plug it into point-slope form first, because that's my go-to. That's the slope, and then you pick one of the 2 coordinates to plug it in. Then you can rearrange to any other form, like slope, intercept, standard, general, whatever you have. Okay? All right, but that's how you do number 7. Again, those are going to stay there all week, so you can see them, you can ask questions. Okay? All right. Today, my goal today was to do 8, 9, and 10. That's kind of the goal today. We're going to go through these pretty quick. On the semester test, I might give you more space in number 8. I went through this on paper just on the practice guide, and I thought there was a little bit there wasn't enough space to do this problem, but I'll make sure that I'll give you the space. I might move like those rest of those problems down to the back page, because I think it's what, 3 pages or something like that? 4? I might spread this one out a little more and then give you less space in number 9, because number 9 you can use all of this area. So I might get rid of some of this space and give it to number 8. So 10 you still need space, you'll need that as best as possible, and then 11, I don't know if you'll need as much space down here for number 11, I might shorten that up a little bit. We'll talk about that tomorrow. Alright, so number 8, this is where you add polynomials, you subtract, it's one problem that kind of covers it all. So it's really 4 problems, but I just want to see kind of how you're going to do this. So you have to add these 2 polynomials together, you have to subtract them, you have to multiply them, you have to divide them, and the division is where you just put them on top of each other. You don't actually have to long divide or anything like that. We'll talk about it. But this is kind of one problem I was trying to, I didn't want to put like 4 separate problems to make this thing like 20 questions long. I just made this one question, and you just have to give me a simplified answer. You can do kind of shortcuts wherever you need to. But you have to show me that you actually know how to add these things together. So to add. So on this is what I would do. Off to the side, I would write this. I'm going to add the f and g together. So if you add these together, what do I need to add? Ignore this stuff. What do I add when I add these 2 things together? Like terms. Which ones can you add?
5 and -12.
5 and negative 12, so that makes what? Negative 7? It's 5 and negative 12. What about the x squared and negative x squared? Those are canceled, and we're left with the 4x. That's what you get when you add them together. Boom. It's like real quick. When you subtract them, and notice the order that I'm doing. I'm going f, the first function, minus the g function. I'm going to subtract them. This one's a little more difficult, because to subtract these 2, you have to write it like this. Why do I have to write it like that? Yeah, distribute the negative sign. That's what we talked about in class when we did these. And distribute the negative sign to the back. So when you do that, here's what I get. I get 5 minus x squared minus another x squared minus a 4x and plus 12. So now here I can add like terms. It looks like the x squares, they don't go away now. It's -1 and -1, that makes -2. X squared. The 4x is by itself, so I'm just going to leave the 4x. It's negative this time. And the 5 and 12 make what, 17? So combining like terms. We did a lot of these in class, but we had them as separate problems. I just made them one. I just used the same two terms. That was kind of the easiest way to talk about it. To multiply, what do we have to do? FOIL. You're taking this item, and you're going to take it times the second. This is probably the one that you'll probably need the most space. This is probably the one that you need to FOIL first, better, and last. That's why I thought this one you needed more space just for that one alone, where you have to multiply the two. What do I get when I multiply that 5 to the back? What do I get?
5x squared
Good, keep going.
plus 20x
Keep going.
minus
60.
yes.
Okay, keep going. Negative x times the back. Or negative x squared, I should say.
Negative x
To the 4.
to 4.
Okay, keep going. Negative x squared times 4x.
Negative 4x to the third.
Good. And negative times the negative 12.
12x squared.
Boom. That's what I'm looking for. Can you even do that? And I might not even, if you don't simplify, I won't count that wrong. Like you showed that you know how to FOIL. Does that make sense? So that you don't have to waste so much space. Dividing. Dividing, I don't want you to do long division or synthetic or anything like that. Just put them on top of each other. Which one needs to go on the top? F? Yeah, 5 minus x squared goes on the top. The x squared plus 4x goes on the bottom. Now, you can't just cancel out things. You can't. If you could factor them apart, maybe you could cancel out certain parentheses. But this, that's all I want you to write. You're putting the right one on the top, you're putting it over the bottom. You understand what division means. It's really quick, it's a simple problem. Okay? Alright, I'm not going to be worried about domain. I'll probably get rid of that direction. I just want you to be able to add, subtract, multiply, or divide. Divide. If the problem was simple, like this, maybe this is my problem. Again, I'm making this problem up. Maybe this is your problem. Like this is what you have when you divide. You can, on the top, I can factor out of 2. Let's make this a 3. So, maybe, on the bottom here, I can factor this apart. It's a trinomial. It's x and x, plus and plus, 3 and 1. Now I can cancel out the x plus 1s. You can do that, but I don't require you to go like long division or anything like that. But I want it just real basic stuff. You know how to add, subtract, multiply is the big one. You want to put divisions, put them on top of each other. I just want to make sure you know how to set them up. That's really what I'm checking for. So I'll probably get rid of the directions about the whole domain thing. I'm not worried about that. I just have the same directions for some of these problems. Okay. Now number 9. I need to warn you. I typed something there and I didn't realize what I typed. I'm going to give you this answer. I'm not going to make it this difficult. I'll talk about what I'm going to do on the test day. I'm going to apologize right now. I didn't even realize what I just typed there. All right. So this is a substitution problem. We did some of these where they're in the book where you had to like substitute answers into a function and then take that answer and plug it into a different function, right? So I'll apologize for this right now. If you want right now, get rid of the -1 here. Scribble that out. Didn't realize what I typed there. I can show you how to do that problem here in a second if you really want to see that. It's not difficult, it's just I didn't mean to type it like that. All right. H of 3. All right, so H of 3, what you have to do is take the H function, plug 3 into it. So here's my H function. Again, I'll give you 3 functions. I'll ask you to plug in. These are the same ones in the book. That's why I type them. You don't even have to use G on this function. So this one you're not going to use right now, today. All right, so for H of 3, plug 3 in here. What do I get? $14? Okay. is you get 9 plus 5. So you do get 14. All right, so what you're going to do is you're going to replace this 14 here, and you're going to plug that into the f function. That's all you're doing. It's substitution. So you're taking the 14 because that was what h of 3 was, and now you're going to plug that 14 in for f. So if I plug 14 in here, this will be my final answer. So 2 times 14 minus 5. That's the type of problem I'm going to give you. Something simple. It's a composition function where you put something inside something. We did a few of these in class, just some easy ones like that. I'm going to pick an easy one, just quick points. Plug it in. What is that, 28 minus 5? So it's 28 minus 5. Boom, there's your final answer. That's what I'm looking for. It's the final number. Your answer will be a number. It'll be a digit. All right. Get how to do it? We did some of those in class. I just thought it was kind of easy, just picking a couple functions. Now, I apologize for that -1. What that actually -1 means, if you actually really want to know, because we never did any of those in class, sorry. I didn't realize what I typed there. What a -1 is, that means that when you get down to this, you still do the h of 3 the same, you still get the 14, but what a -1 means here, if they actually have the -1 sitting there, that means instead of plugging 14 in for f, like plugging it in, the 14's over here, and you solve for x. So instead of plugging 14 in, going 2 times 14, the 14's over here, and you solve for x. You'd have 5 across, and you divide by 2. Is that 9.5? Something like that. That's how you do it. I'm not going to do one of those. Sorry, I just didn't even realize what I typed there. I must have been typing out the pre-calc or calc test. I went right to yours after. Didn't realize what I did there. All right, we're good on 9. Okay, let's move on. All right, 10. This is my last one today. You have to use long division. Okay. Long division on this one is the one where you have to set up the house. You plug the number in the house. You have to long divide it out. I'm not going to guarantee that this could be a long division problem. I might make it a synthetic division problem. So if you need to know both, we can go through both of those today. On this problem, I cannot do synthetic. The reason why I can't do synthetic is that this is a huge binomial. Like it's actually a trinomial. So you can't do synthetic on it. So you have to do long division. The thing I have to warn you of, if you do this one, I think we did this one in class one day. This is one of my examples I did. You have to fill in all the zero terms as well. You do have to have all the zeros accounted for, all the letters, all the terms. When you look at this problem, which number goes in the house?
18.
Yeah. Yeah, that first item goes in the house. So that 18, x to the 4th, 9x to the 3rd, 3x squared, 0x, and a 0. And yes, you have to have everything accounted for, including all the way up through the zeros. You have to have everything. So if they're missing terms, fill them in. The biggest term is where you'll start, and then you'll count down. You don't need to worry about 5th and 6th because you just go down. All right. On the outside, 3x squared, 0x, and a 1. Yes, you have to even have the zeros correct on the outside if they're missing anything. That way everything is accounted for. Okay, what do I need to multiply on the 3 to make the 18? 6x squared, heard that? Okay. I have to multiply by 6x squared here, so if I take all these times 6x squared, I get 18x to the 4th, 0x to the 3rd, because that'd be 0 times 6 is 0, and then 6x squared, because that's 1 times 6x squared. So that's taking that item times everything on the outside. That's how I'm getting this. Then I have to switch all the signs and add straight down, because you're subtracting technically. That's why I changed all the signs. That makes 0, this makes 9, and this makes a -3, and then I bring down the next item. And then now I start all the way over again. Okay? So now I'm trying to figure out, okay, what do I multiply on a 3x squared to make a 9x cubed? 3x, okay. Multiply by 3x. So taking everything here times a 3x, I get a 9x cubed, a 0x squared, and a 3x. That's taking everything times the 3x on the outside. I switch all the signs. That's negative, negative, and 0. I know 0 is 0. You don't really care if it's negative or not. But you add it straight down, that's 0. This makes a negative 3x squared and a negative 3x. And I bring down the last term, which is my 0. And then I try to divide it again. So what do I have to multiply in a 3x squared to make a negative 3x squared? Negative 1. So we'll multiply by negative 1 here. So multiplying that by negative 1 is negative 3x squared, a negative 0x, and a negative 1. Draw a line, switch the signs. So that makes positive, positive, positive. I go straight down, that's negative 3x, and a plus 1. And that's my remainder. That's what I'm left with. Yes, you can have remainders. Okay, questions? All right, now I'm going to give you the last 7-8 minutes here today. You can work on a practice guide. You can start kind of preparing for your, maybe you're going to take a retake this week over the Chapter 9 test that we just took. You can kind of mentally prepare. When is our semester test this week? Thursday. Now you're thinking, okay, we've got a couple more problems left. We'll do those right away tomorrow. We'll do those next 3. That we'll hopefully have enough time for those. On the semester test, I have to change one of the last problems. I warned you of this I think it was last Thursday I warned you of this. It was dropped on us last week that we have to change one of your test questions. It has to be a race format question. Every class has to do it. So what I did is I changed one of the last problems where on the last problems, that's ones where you're drawing the hyperbolas and ellipses and stuff and hyperbolas. And I'm going to make it a race format question where you explain when you look at the formula, like what type it is and how you know, and you can explain it in the words. So it's kind of like, it's a very similar question to those last 2 that we did on the Chapter 9 test. But it'll just go more in depth with that. Okay, that way you can at least write, 3, 4, 5 sentences about it. Okay? All right, questions at all about the problems we did today? Now you're thinking, okay, we're going to do 3 tomorrow. That means we don't have anything for Wednesday. We're on an early out Wednesday. What we're going to do that day is I'm going to break you guys up into little pods, kind of like you are now, but it'll be different. There'll be bigger numbers, maybe like 6 and 6. But what we'll do is that I'm going to separate you out by what you want to work on. So I'll do this tomorrow, by the end of class. I'll take a little survey from you. I'll take a little piece of paper and I'll get kind of your opinion on certain problems on your semester test. And then come in Wednesday, I'm going to separate you by what your test questions were. Yeah, sorry, we forgot to communicate. So, totally forgot to communicate. So on our on semester test day on Wednesday, I'm going to come get you, and what I'll do is I'm going to pull some of you guys, and I'm going to pull you up here, and we'll go through the problem that maybe you were very similar about that. Hey, I don't know how to do this problem. Let's go through examples of it. And so that's why the survey on tomorrow at the end of class is kind of important. It tells me what problems you're not comfortable with, which ones you still need to work on. And then on Wednesday, we'll have you separated into those groups. And what we'll do is we'll rotate around the room where you'll try certain problems. Like a certain pod in here, we'll just try a race format question. Can you do it correctly? One group will try problems that you're not comfortable with. One group, I'll just give you free time where you can just work. Does that make sense? So there'll be little stations, and I'll rotate you every 5-6 minutes. That way you get a little chance to do a race question. I'll check it, see how you're doing, see if you've got the correct format down. You'll have a couple minutes where you come up here, and we'll keep doing that. So the entire class, you might get to see me 2 or 3 times to go over different problems you want to see. Does that make sense? So we'll separate you that way. Because nothing's worse than you're trying to go through your practice guide, and you have a ton of questions on it, but you didn't have time to ask them. So that's kind of Wednesday. So we have about a 30-some minute class that day, 32 minutes, 35 minutes, something like that. But it'll be just kind of like things you get to work on, get your semester test ready to go, practice guide, whatnot. Okay? All right. Formulas are on the board for semester test day. There they are. And back there. Those are staying up there. So I don't think there's anything else I need to put on the board that day. I don't think so.
No, it's still.
Okay. All right. Well, that's it. I forgot to take the sorry.
Yeah, I was like,
Yeah.
you should go back in there.
Yeah, it was probably a good choice.